So this is worth thinking about a little bit more, so I wanted to add another little podcast. Every ton of CO2 emission adds to global warming. So often you hear the so-called committed warming argument, where we say we have already emitted so much CO2, we are looking at warming here and looking at CO2, cumulative CO2 since 1850. And the idea is that even if we stopped emitting CO2 right away, the warming will continue for some time because of so-called committed warming, as the emitted CO2 begins to be moved into the ocean, the land, the feedbacks happen, the atmospheric accumulation, and so on. But the most important point to remember is that just because there is committed warming doesn't mean that it's hopeless to stop emitting more, because each additional CO2 emission is going to add to global warming. So the cumulative CO2 idea comes from the fact of this relatively linear relationship between cumulative CO2 since 1850 and the warming, and the various scenarios that we looked at in terms of SP1 1.9, the most benign SP1 2.6, which is somewhat acceptable below 2 degrees C, and then business as usual. You can see that the warming range is going to keep increasing. So this is what is important to remember, that the sooner we start cutting the CO2 emissions, the better. I closed this window screen, but now some wind is coming from the other window, but the hiss should be lower. So sorry about that, but let's live with it. So future cumulative CO2 emissions differ across scenarios and determine how much warming we will experience. So 1850 to SSP 1.9 will give us 2030 gigatons CO2. So these are gigatons here, and the SSP1 2.6 will add some more. SSP2 4.5, which is middle of the road, will bring us to over 2040, and SSP 8.5, which is the business as usual, the worst thing we can do, will bring us to 2050 gigatons CO2 by I think that should be by 2050. Yeah, between 2020 and 2050. So the idea is, if we want to hit the global warming targets by 2100, how fast we have to start drawing down and what we should aim for. So there is the net zero argument about how quickly you have to hit net zero and what trajectory we have to be on. So the near linear relationship between the cumulative CO2 emissions and global warming for 5 illustrative scenarios until year 2050. So this is showing not years but total cumulative gigaton CO2 and the warming we would expect by 2100. So I think actually no, SSP 8.5 by 2100 will give us in the range of 4 to 8 degrees centigrade or so. So this is by 2050. So you can see how we have to track the emission trajectories to be able to hit the targets. People also use this using the emission rates of CO2 that we are at now, something in the range of 30 some gigaton CO2 or 40 some gigaton CO2 equivalent when you add the non CO2 greenhouse gases, which is very critical because these cannot just worry about CO2. We also have to worry about other greenhouse gases, as we saw before. So global warming between 1850 to 1900 and 2010 to 2019 is an average about 1.07 with a range of 0.8 to 1.3. That's the likely range. And then there is historical cumulative CO2 emissions from 1850 to 2019 in gigaton CO2, which is 2,390 plus minus 240 is the uncertainty there. So that's the likely range. Then if you want to look at approximate global warming relative to 1850 to 1900 until the temperature limit chosen to be 1.5, 1.7 and 2, this is really the best we can hope for. We are probably going to get past 1.5 very soon. There is a whole debate about what would that mean. Will something dramatic happen? Probably not, because already many bad things are happening in terms of extremes. So there will not be any major sudden change. And also the question is, if we shoot past 1.5 and then we come back, how long can that overshoot be? And what would that mean in terms of the impacts and so on. So all kinds of details exist, and many social scientists especially also don't like the idea of how many years remain to hit the targets of CO2 to meet these warming targets, because many people, including the UN Secretary General at one point and Greta Thunberg, said we only have X number of years to save humanity. These are not very accurate statements, so I'm against it. There's a lot of literature arguing that this is not a good way to narrate the future. Nonetheless, additional global warming relative to 2010 to 2019 until temperature limit, we are at 1 point some, so this is 0.43 remaining, 1.07 as we saw here. 1.7 will give us a room of 0.63 additional warming, and 2 degrees will give us 0.93. And estimated remaining carbon budgets from the beginning of 2020 in gigaton CO2, using this idea that the linear relationship between cumulative CO2 and warming can be used to estimate the remaining. So it's an estimate. That's what I have to remember. There are a lot of uncertainties. That's why it's dangerous to convert it to number of years remaining to save ourselves. Okay, likelihood of limiting global warming to temperature limit here 70. If we keep the probability of limiting global warming to just 17%, then we will allow a lot of emissions in each scenario, from 900 gigaton CO2 in the future from 2020 for 1.5, 1450 for 1.7, and 2300 gigatons for 2 degrees C. But as we increase the probability with which we want to limit it, the allowed CO2 emission of CO2 in gigatons CO2 would go down. So we will go from 900 to 650. If we increase it to 50% probability, it will go to 500. And if we want 83% assurance of not exceeding 1.5 degrees C, then we will be allowed to emit only 300 gigatons CO2 more from 2020. How to do that is another question, but this is just a calculation, an estimation of how much CO2 remains. And similarly, if you increase the allowed warming, of course allowed emissions will go up as well. So for 83% it will go from 300 to 550 for 1.7, 900 for 2. Of course there is the whole question of what are we even capable of accomplishing, because all of these rely on doing carbon capture and sequestration and hitting net zero and decarbonizing and so on. Right? We are not there in terms of scalable solutions. So variations in reductions in non-CO2 emissions associated with these, higher or lower reductions in accompanying non-CO2 emissions can increase or decrease the values on the left by 220 gigatons CO2 or more. So that's how much additional warming is implied by cumulative non-CO2 greenhouse gases. So we cannot just focus on CO2. We must adjust these numbers with non-CO2 greenhouse gases that are also going up along the way. So let's leave that here. This is a shorter one, but it doesn't matter, because this is still very important in terms of knowing two things. One, all indications are that the warming, global warming, okay, remember global warming then has to be translated to regional patterns, and especially regional impacts and regional climate impact drivers. That's not an easy task, but we know that each additional warming is going to give us more and more climate impact drivers regionally, so that's not a very difficult thing to worry about or difficult thing to understand. So given this near linear relationship between cumulative CO2 and global warming, global mean temperature rise, we have ways of figuring out the remaining amount of CO2 we can, or CO2 equivalent we can emit to assure ourselves to remain within these global warming targets of 1.5, 1.7 and 2 degrees C. Okay, one can debate about whether the impacts corresponding to those global warming levels of 1.5, 1.7 and 2 are very well known, but that's a different question. You have to just think about risk. How do you perceive the risk? Already 1 degree C warming has happened, and we have seen how events have changed in terms of heat events, droughts, floods, cyclones and so on, health. And how do you want to put uncertainties on the impacts, or do you want to play it safe and go for the best case scenarios and know what is the worst case scenario we are able to create with business as usual? So it's not just natural science, it's a very complicated socio-economic, social science, financial, economic issue that humanity has to deal with, and keep hoping that technology and science will keep on giving us pathways to get there safely. Okay, so let's leave this summary of working group 1 here.